Hello, my name is Seda Mukhtar, and this is my phase 2 presentation for predicting Dogecoin prices. During phase 1, we were able to go through most of our exposure data analysis for Dogecoin, Bitcoin, and Ethereum prices. We were really able to see the historical data of Dogecoin, see the times that it just randomly peaks and sometimes it just randomly falls, which we said is could be based off a lot of social media, but and we do want to look at that and what happened at those peaks. However, the first step that we're going to take and we're going to go through during phase 2 is we're going to look at how we can predict Dogecoin prices using just the historical data and basically figuring out what machine learning algorithms we want to use for that. And later on in phase 3, we'll be able to make those algorithms much better by including our sentiments into the Dogecoin historical prices and see if we can make our models better. So there are a couple models that I decided to use for the prediction of Dogecoin prices. Those are supported vector regression, linear regression, decision tree regressor, random forest regressor. So the first one that I am using is support vector regressor, which is a part of the support vector machines, which is mainly used for classification, but the algorithm and the approach that is being applied for support vector machines is also helpful in using it as a regressor. And so the main feature of how support vector machines work is basically by keeping a hyperplane and a maximum margin. And so support vector regression is basically a generalization of the classification, which is founded on the support vector machine, and then it will return a continuous value to output. So from our historical data of Dogecoin, we were able to use 80% of training data and 20% of test data, and that's how we split our tests and training data. Once we did that, we used our SVR and created our model, and this is what we came up with as our accuracy score, which is a 0.59, which is completely not good, especially when it comes to prices of stocks and cryptocurrency, as the smallest difference makes a huge difference in it. So let's just give an example of what that actually means. So we have a point here where our prediction, our actual value of the price was 0.14, but our algorithm predicted that the price is 0.05, which is obviously not good. We can do one more just for the funs of it, where our actual price of Dogecoin was 0.1 and our algorithm predicted it as 0.01. So we can also look at this through an actual graph. As you can see, when there's a lot of distance between the prediction and the actual price, and also we see these random peaks on the actual price that our algorithm obviously did not account for at all. So we could say that this is because of maybe the tweets or maybe the social media and those random things that occur because this is a meme coin, and it's also very volatile. But I feel like the volatility could have been predicted by a model, but we'll see. Let's see if there's another model that can do better than SVR. The next model that I tried was linear regression. Linear regression is one of the easiest algorithms in machine learning. It is a statistical model that attempts to show the relationship between two variables with a linear equation. So first, let's talk a little bit about what regression is. Regression analysis is basically a form of predictive modeling technique, which basically investigates the relationship between a dependent and independent variable and it involves graphing a line over a set of data points that most closely fits the overall shape of the data. And it shows the change in the dependent variable on the y-axis to the change in the explanatory variable in the x-axis. So there's kind of like 3 major uses of regression analysis, and those are like determining the strength of predictors, forecasting an effect, and trend forecasting. The regression analysis basically predicts trends and future values, so it can be used to get point estimates like the price of cryptocurrencies. So during linear regression, we're interested in things like y equals mx plus b, and we're basically trying to find the correlation between x and y variables, which is basically seeing that for every value of x that has a corresponding y, kind of seeing what that is, if it's continuous. So again here, the tests, so our tests and training sets for all the models that I trained are exactly the same. They're both 20% testing, 80% training. So the accuracy for linear regression was also not good. So we can also just look at one price and see how much of a big difference it made. So we can see here that the price of that, when the actual price was 0.09, our model predicted it would be 0.2. So let's look at this as the graph. As we can see here, when we look at the graph, again, there are these peaks that are definitely 100% not accounted for. We do see that some of the distances between the predicted and actual prices have gone down a little bit, but there's still some that are like super huge. And again, these peaks that are definitely unaccounted for in our models. The next model that I tried was decision tree, which is basically a tree-shaped diagram used to determine a course of action. Each branch of the tree represents a possible decision or occurrence, and it can be used on classification and regression problems. During classification, it determines a set of logical if-then statements to classify problems, and during regression, it's used when the target variable is numerical or continuous in model. So we fit a regression model to the target's variable using each of the independent variables. So using our decision tree model, we were able to get an accuracy of 0.78, which is much better than the other two, and honestly not that bad. When we look at the graph for this, one thing that actually that stood out to me was that we were able to make a really good progress in predicting this one peak. We still have one peak left where we did not account for at all, but we were at least able to predict this one peak. So I was thinking maybe this peak has nothing to do with social media or anything, and we can actually, it's something that's predictable with just the historical data. But this one could still have an effect because this one might have been a peak because of something that happened on the news, social media, Twitter. So we'll see if we are able to add sentiment, if we can get rid of that distance and account for it as well. The final model that we used is random forest regressor. So the idea behind it, random forest, is that it takes not just one computation as your final result, but a combination of multiple values, and it tries to calculate the results. It's basically an ensemble model that consists of many decision trees and predicts them by making an average of each decision tree. And random forest is a really powerful model, and it's usually very accurate as well. So using that, we were able to get an accuracy of 0.76. And we can also look at that on the graph. And just the graph of the random forest and our accuracy score is actually close to the same one as our decision tree. As I said before, for the decision tree, we were getting close to getting a prediction on this peak, but however, there's still a big gap here, which makes my suspicions of thinking this could be because of some social media more suspicious. So basically, again, we'll try to see if we can make our model better and see if we can fix this gap by adding our sentiment into the historical data of Dogecoin. Speaking of sentiment, sentiment analysis is a machine learning tool that analyzes text for polarity from positive to negative, and does that by training machine learning tools with examples of emotions in text. And machines automatically learn how to detect sentiment without a human input. So we were able to obtain the Twitter data by getting API from Twitter and using the function tweetbee on Python. So this is just the first few tweets on our, and we put it into a data frame as well once we got the tweets. So this is just the first few ones that we see. But once we were able to obtain this, we did a lot of cleaning as our initial. We wanted to get rid of anything with a hashtag, backslashes, any website, and there were a couple other things that we did not want to be as a part of our data frame, including retweets, because we don't want any redundant data. So once we were able to do a lot of cleaning on our data frame, we finally got our clean tweets that we were going to be using for our sentiment analysis. So this is basically the result of our sentiment analysis. Of course, we first found our subjectivity and polarity. We're using TextBlob, by the way. TextBlob is what we've been using for our sentiment. So once we did that, we were able to find the sentiment and see if our tweet is neutral, negative, or positive. And also, I think I forgot to mention this, but our Twitter is starting January 1st, 2021, and I only got 2,000 tweets was my max tweet, so it was probably mostly those only in July. So this is just basically a scatter plot that shows the subjectivity and polarity of the tweets. So for example, the tweet right here, this one right here at 1:1, basically means that this tweet is very positive and it's also very subjective, while this one all the way on the left is very negative and very subjective. And we see that a lot of our tweets are more on the neutral / positive side. The final thing we did for phase 2 was basically look at the number of tweets and see how many were neutral, positive, or negative. Now, the next step for this project is basically implementing these sentiments into the Dogecoin historical data and see if they can make our models that we saw, the 4 models that we saw earlier, if that can make it better and, increase our accuracy score. So the idea here is, one, Twitter only kind of allows me to go through only 30 days back, even though I asked for tweets starting January 1st, 2021. Most of my tweets were just in July, and I'm guessing that has to do with some API thing. However, still the goal here is, for example, if I'm trying to get a plot like this for every day in July. So basically, let's assume that this graph is for July 1st, Monday, July 1st. And as we see here, the max here is neutral. So I would say on Monday, July 1st, most of the tweets were neutral. So we're just going to say that the sentiment for Monday, July 1st, for Dogecoin is neutral. So on our Dogecoin historical prices, we would have a column that says sentiment, and for that would put it 0 for Monday, July 1st. So I want to do that for every single day until, well, July 28th is today, so July 28th. However, it's there's just one issue here, as Twitter is not really letting me get data for a specific day, but once I'm able to figure out how to do that and able to put these sentiments into the Dogecoin historical prices, then we can rerun our models and see if they got any better. The second thing I want to try to do, if I have time, is also add in news sentiments. So either from CNN, Yahoo Finance, or any other news outlets, and see if I can find sentiments for that and add them into our Dogecoin prices as well. Yeah, and that's all for phase 2. Thank you.